FPAs, one of the questions that comes up is asking, okay, so there's components and routing, but I want to understand this a little better, please. And so clearly, this is what we want to be able to do. So a couple of things that are important. One is to remember that a CAB is a computational analog block. There's also an equivalent of a CLB. So in digital, you would talk about a computational logic block. You can actually build, at least what we understand now, you can actually build both analog and digital blocks in the same fabric and actually in the same routing infrastructure. So that gets in a lot more detailed question, but you ask the question, well, what does the routing look like? Well, we'll usually talk about these blocks, which are C blocks and S blocks, connection blocks and switch blocks. This is, by the way, a classic architecture. Most FPGAs, commercial or otherwise, tend to follow along these general lines. And so you would kind of expect something along these structures all the way through. What you typically get is what we typically call Manhattan geometry. And in case it's not clear why would I call it a Manhattan geometry, here's a picture of Manhattan in winter in the snow. And one of the things that you notice is that it's a lot of very straightforward blocks in X and Y direction. And so with a lot of sort of buildings in between. Now, Manhattan's not the only city that does this. In fact, if you look at some more of the newer cities, say like Phoenix or Salt Lake City and other places, have even more of a grid-like system. But the whole concept is to imagine I have a building, I have roads that go on the side of them, and then there's intersections. Well, the same thing happens here. I have my cabs, which think of as my building. I have my connections out to it, and then I have the intersections, and I have to figure this out. And there are many times when it just takes a little bit of time to go, oh, this is exactly trying to just route things between computational components. Now, in the cabs themselves, there will often be components and additional routing. Routing that goes straight in, routing that may come out into output lines as opposed to also input lines. And there'll be different kind of routing topologies. In theory, you can do a lot of different things internally in the structure. This tends to be a pretty standard approach for the kind of routing crossbars that you see inside the cabs themselves. So notice first just how much of this is routing compared to components. So if you're only, so obviously you typically want to minimize the routing, but in the analog case, remember the routing can also be your friend. So that changes a little of your conversation. The C block is, so once you get to the cab, the C blocks is simply just the routing basically onto the street. So basically you can just pathways off the cab onto your street that you get to work with. Pathways off the cab onto your street. Kind of makes sense. Ends up just being a very simple crossbar. There's really not much else to it. Obviously you have to think about which side of the street the lines can come on and so forth, but other than that it's pretty straightforward. It is, and then you get to the switch block, and that's where a lot of things get interesting. Because here, you often have routing that allows you to go between, say, north, west, east, and south. It usually amounts to having like all sorts of routes in between, and maybe multiple routes, so maybe I can go north, west, and east, south at the same time. So I can imagine doing that with a whole bunch of floating gate elements in switch configurations. Now I could imagine having not just nearest neighbor, but I could have like, next jump, so maybe like I'm switching lanes in the intersection. I can imagine that. But the other thing to notice is that often you'll think about there being a buffer here. Maybe that you may use, you might not. And we will use different things personally in our design. But that buffer then also says, is there an opportunity for additional circuitry there? Because that might be very valuable. Imagine that I want to have something that not only buffers the signal, but maybe gives me a little bit of a delay in the signal. So imagine it's a first stage of a ladder filter topology. I could imagine different concepts here and utilizing all of those for different computational reasons. The minute I start thinking about the routing fabric as computing, that changes the way I might talk about these various aspects. But the key is this allows me to kind of dig deeper into what do all the computational blocks themselves look like.